It comes down to risk and who takes the risk. Historically, networks don't like to take risk, whereas developers obviously and people trying to build these assets want them to take more risk and don't want to have the risk themselves. So it's really hard to balance that, and I guess that's where the regulator has to come in and kind of get us to agree on who takes what risk. Distribution is almost playing catch up with transmission in the sense that at transmission you have a balancing mechanism. Distribution is only starting to have distribution system operators, DSOs, and also a flexibility market itself. Until you have that flexibility market, it's very difficult for the network to take that risk because there's not a lot they can do when things go wrong, right?
The kind of impact that this has, the reason we're all talking about this is because obviously connections reform is sort of needed because of the level of upgrade work that's been triggered. There is a very clear proposal in connections reform to have more ambitious, less pessimistic assumptions regarding battery operation, which should hope reduce some of those kind of connection timeframe delays.
Grid connections are one of the most pressing subjects for anyone looking to connect a renewable project or battery storage system to the grid. And connections reform will set the precedent for all projects in the connections pipeline. Today, Catherine Cleary, Specialist Connections Officer at Roadnight Taylor, and Joe Colebrook, Head of Grid Connections at Innova, join Ed Porter to discuss all things grid connections and connections reform. If you're enjoying the podcast, please hit subscribe so you never miss an episode and give us a rating wherever you listen. Let's jump in.
Hello and welcome to another episode of Transmission. Today we have two guests for you, Joe and Catherine. Welcome to Transmission.
Thanks very much.
Thanks for having us.
And to get started, Catherine, can I come to you? What is your role? What do you do within the energy space?
Yeah, thanks. So I work for a company called Roadnight Taylor, who are a very small grid connection consultancy. So I'm one of their connectologists, which is basically what it says on the tin. We advise and help get all types of customers connected to the grid. So that might be demand, generation, kind of really large scale transmission projects, and much, much smaller, sort of, anything down to a kind of community energy scheme connecting to their local distribution network operator.
Superb. Joe.
Yep. Hi, thanks for having me. So I am head of grid connections at Innova. I manage a team that basically deal with all the networks in the UK. Innova are a renewable energy business. So our long-term mission is to build energy hubs with multi-technologies to try and help end users reduce their impact on the grid.
Superb. And so hopefully we've got a bit of a mix from sort of the commercial and the technical side today. And to kick things off, I think we're going to do a bit of a Connections 101. So Joe, starting with you, from the commercial side, what does the process look like in terms of going from idea around energy project through to connected project going live?
Yeah. Okay. Yeah. So, one of the key parts of grid connections is all about managing your agreement and your contract with the electricity network. So when you first have a project, so you'll find some land, you'll talk to a landowner, you will apply for a grid connection, and that sort of sets off the process of how you're going to connect to the grid, how much it's going to cost. Once you've got that, you'll then sign that offer, and you'll basically keep collaborating with the energy networks to, as you develop your project, they will develop their part of the connections. They often need to do some work to connect you to the grid, and you'll basically work through with them over your lifetime of your project, and then you'll get to sort of the end where you start operationally, and you start being in operation. And at that point, you'll have an agreement of how you work with the energy network. Okay. And what you can and can't do.
Okay. And best case, kind of worst case, what does in terms of time frame for that process?
So it depends. Like distribution and transmission are very different. So distribution, you could be looking at assuming you've applied for a connection before planning, which is the general way you do it. You could be looking at sort of 3 or 4 years, maybe 2 at best case, whereas at transmission, you need sort of, even once you've got planning, you need sort of 3 years to do all the procurement and to do the works, because everything's a lot bigger. things take a lot longer.
Okay. And we just talked about distribution and transmission there. So maybe just to remind people the difference between those two networks.
Yeah. So distribution is your, I kind of like to explain it as your distribution is sort of your local level network. So it's a bit like your B roads and your green roads, maybe even your A roads, if you're using the road analogy. Whereas transmission, as the name suggests, is there to transfer bulk power across the country. So it's more like your highways. It's there's less of it, but it's much higher power that is going through it.
Okay. And Catherine, so from the engineering side, so obviously Joe has kind of made his application and there's the commercial process going on, there's the kind of contract management going on. But from the engineering and technical side, what's going on in the network operator's mind?
Yeah, so I guess, if I'm sort of sitting on the engineering side, once you get that application from a customer that says, I'd like to connect, there needs to be some kind of evaluation of the impact that customer is going to have on the network. So, if you were to take the example of a sort of maybe a 50 megawatt battery site, your network engineer would now look at saying, okay, well, what actually happens when that battery wants to charge from the network? So when they're drawing power down, what are the kind of power flows that go through the assets in the network? And that might identify pinch points. So, particular pieces of equipment. So it could be sort of overhead lines or substation equipment that needs to be upgraded. And that's a kind of, effectively a kind of a power flow analysis that might look kind of, I guess, in quite a lot of depth at the different loadings on the network at different times of year, things like that. So there's quite a lot that goes into that kind of consideration. So that's the first thing. And obviously they need to consider things like when the battery was exporting as well. So all the kind of operating conditions. But the second point is that physically, Joe's 50 megawatt battery needs a point of connection. So actually, apart from the load flow kind of engineering piece behind the scenes, we need to look at what are the physical assets that I just need to be able to build out to extend the network to connect Joe. And in the past, perhaps that's been quite a simple exercise. And as we're seeing more and more applications come in, more and more competition for customers connecting at maybe the same substations, actually that physical infrastructure, just extending the network out, is becoming quite challenging.
And which of those two is kind of the bigger problem, right? So is it the kind of the almost like the heat map modeling of what the network looks like and where are the pinch points? Or is it the kind of, we need to just bolt on an extra transformer and an extra sort of,
Yeah, so it always used to, I think I'll simplify. It always used to be that it was the wider kind of power system flows that would do things like delay your connection. So I'd work out that actually there was an overhead line that was overloaded. We needed to build a brand new transmission circuit. Sorry, Joe, you're now going to have to wait for 2037 for your connection date. So that was the kind of the things that spell really bad news for a project. Whereas, okay, worst case, if I have to extend my network out to you, maybe I have to go and extend a substation, perhaps lease some extra land, that was sort of the worst case scenario on the physical side. I think now we're in a situation where the physical side is beginning to catch up as being an issue as well, because we are seeing so many connection applications that you're getting to the point where, I think some of the largest transmission substations that are being planned, just in order to physically connect everyone, you're needing enough bays, bay is what we connect each project into, that you're getting substations which are sort of, football pitch size substations. You imagine kind of going through the planning process to say we'd like to build a football pitch sized, metal substation, which is going to be loud and noisy in your backyard. And that becomes a bit of a deal breaker. So that physical infrastructure piece, I think, is becoming really important.
And I mean, there's now some where they're even having to build 2 new substations because the first one isn't big enough. So yeah, it's and that's at the 400 kV level, with the transmission level, which is quite phenomenal when you think about it.
So how is battery operation being considered in that process?
So I think it's a really important point because historically, network operators have taken a very risk-averse approach to batteries. So they've said, well, we don't know absolutely how you're going to operate. So we'll assume the worst-case scenarios. So we'll assume that you're exporting when other generators are exporting, you're importing when other customers are importing, which obviously triggers kind of more network reinforcement. It shows up more pinch points. I think the whole industry has agreed that's not the right approach. It's overly pessimistic, but actually agreeing what is the right approach is quite difficult. So we could go the whole hog and assume that batteries always do the right thing and they always help the network. That might not be possible. A battery might have a limited sort of state of charge or something like that. So at the moment, we're in a situation where the transmission network operators and the transmission system operator, NESO, so the National Energy System Operator, have some construction planning assumptions is what they're called, quite technical assumptions, which basically hold batteries in a sort of neutral position. So we assume they don't help because they might not be able to, but we assume they don't make the situation worse. At distribution network level, that's not true, and DNOs are still in a relatively sort of pessimistic scenario, assuming that batteries might make constraints worse. And that difference is gonna, we'll probably come on to it later, is sort of, triggering a bit of a kind of an issue.
Okay. And are the DNOs allowed to kind of make their own mind up about this, or is it kind of baked within a more centrally planned process?
So there are some codes. So all the DNOs have to abide by certain engineering standards, which the Network Association publish. So there are some basic provisions that talk about sort of the security of supply that network operators have to provide. They do actually have quite a lot of flexibility. So I think if anyone says, "Oh no, we wouldn't be able to consider the flexibility of a battery asset," you could point them to some sort of some of the distribution system operator parameters, which say no, actually you could be a bit more flexible. But it does need more modelling. So
to add one more bit, so I think it's a really good point around batteries could import or export at nearly any time, particularly if they're doing frequency response. And if you go back to 2022, batteries by and large nearly all did frequency response. So kind of always either importing or exporting, depending on kind of where the frequency was. If we kind of accelerate to 2024, we've got like 4.5 gigs of batteries, 1.5 gigs more or less does frequency response. So 1.5 gigs needs flexibility in both directions, and so could hinder the network in some cases, theoretically.
Yeah.
But the bulk of the assets that are there, the 3 gigs that's left, they actually aren't providing frequency response, and so they very much explicitly could be doing the right thing for the network always. And so to me it feels like there could be a kind of an agreement that's reached where for some assets, yes, they do frequency response, but for others it's much more of a some assets will kind of be always doing frequency response, but other assets could be much more curtailed or have network management orders placed upon them. Joe?
And that's not a bad idea. I think the thing that we got to think about here is that it comes down to risk and who takes the risk. And the more aggressive your assumptions, the more risk that the networks have to take. And historically, networks don't like to take risk. And in fact, there's not really an incentive for them to take a risk. Whereas developers, obviously, and people trying to build these assets want them to take more risk and don't want to have the risk themselves. So it's really hard to balance that. And I guess that's where kind of the regulator has to come in and kind of get us to agree on who takes what risk. And I think also distribution is quite different, because distribution is kind of trying to almost playing catch up with transmission, in the sense that at transmission you have a balancing mechanism. Distribution is only starting to have distribution system operators, DSOs, and also a flexibility market itself. So some of these are more advanced than others, and until you have that flexibility market, it's very difficult for the networks to take that risk, because there's not a lot they can do when things go wrong, right?
I suppose, but coming back to connections reform and the kind of impact that this has, the reason we're all talking about this is because obviously connections reform is sort of needed because of the level of upgrade work that's been triggered. There is a very clear proposal in connections reform to have more ambitious, less pessimistic assumptions regarding battery operation, which should hope reduce some of those kind of connection timeframe delays.
Okay. And we've kind of seamlessly moved into connections reform, but I think we absolutely should, instead of perhaps talking about what connections reform is, which has kind of absorbed a lot of the airwaves for this year, I think
talked out on that.
Yeah, I think a lot of the industry are. I think we should maybe look forward. So instead of kind of talking about what that particular reform looks like, I'd like to kind of get your take on actually what would be sort of the ideal solution. So if you were kind of given kind of free rein to do whatever you would like in terms of where that reform gets to, what would it look like for you? Joe?
Well, I get to go first. If I could do anything I like, wow, that's a lot of power. But no, so I think we're actually, getting into quite a good place. Like, fully acknowledge that the previous system didn't work and something needs to change, right? And the current proposals by NESO are pretty good. They go quite a long way to fix a lot of the problems. But I think for me, it's we still need to acknowledge more about how the developer business model works. You naturally, as projects get more developed, you spend more money on them, you de-risk them, they become more certain. So when a project first starts, it's speculative, right? And I'm going to use the word speculative. I know it's a bit of a controversial term, but whenever you start a project, even just getting a piece of land, that is a speculative project. You have to go through the process to make it not speculative. Every project that was ever built, whether it's a nuclear power plant or something else, was speculative once. And so it just needs an acknowledgement of how that process works, and to blend that in with the connections process itself and how we manage the queue. So for me, I think queue management milestones are really important because they set expectations and they set the agreement of how you're going to develop your project. So I would absolutely keep those in. I think that with the capacity pots that we're going to have introduced, the danger is at the moment is we're going to set the limit of what we need, but that the one thing that really doesn't deal with is the fact that some of those projects will never get built. Like, it just, by nature, the way the business model of developing works. So we need attrition in some form, and Innova have suggested in our recent consultation, we suggested to actually do something which we do in our business anyway, which is apply a project success weighting. So if you've got a queue and, some of them have only got land rights, you would apply, let's say, a 50% project success weighting. So a 10 megawatt project will actually look like a 5 megawatt project in the queue. Or if you've got planning, it might be more certain, right? So if you've got a whole queue of everything's got FID, or everything's had an investment decision made, that's 100% basically they're going to be built. You're like, well, we're not going to let anyone else in. But if you've got a queue full of projects with land rights, you'll go, well, I'm going to keep letting people in because a lot of those won't be built.
Okay, and maybe two things in there. So one, you snuck in connection pots, so we'll come back to that.
Sorry.
But two, in this concept of like derating a connection, if you derate it to say 10 megawatts to 5 megawatts, and then it looks like 5 megawatts in the queue, that might be fine in terms of physical connection that's available. If it then, but then as it gets close to delivery, it becomes 10 megawatts. That might trigger wider reinforcement works. Is that what you mean?
So I guess there's maybe we need to explain how a queue works in connections, right? Because we've talked about there's the physical work you need to do at the substation, the local work, right? That obviously you need to plan for the 10 megawatts that project is, right? You can't plan for a 5 megawatt project and then build it later as a 10. It doesn't work. But the wider works, so a queue is there is a queue behind every piece of work. So when people talk about a queue, it's not necessarily a big long queue. It's projects that have to wait for a certain piece of reinforcement to be done, and some projects have to wait for multiple pieces of reinforcement. So that piece of reinforcement is enabling lots of projects. So that is more what I'm talking about, where this project success weighting, you will allow more projects. You would assume more projects are going to be given a connection date when that's built. So more projects, it will enable more projects when that's built, acknowledging that obviously some of those will fall away. And then by the time hopefully that piece of work is built, a load of all those projects have developed at the same time, and they've all got planning, and some haven't, some have. And it kind of works out that you get the right amount of capacity for that piece of reinforcement. Obviously the risk is that you over connect it, or you have an oversupply. And I think as long as that risk is clear, and there is clear who's taking that risk, whether it's the network who has to pay more in balancing mechanisms costs, or it's the developer who would get a delayed connection date, as long as that's clear, I think it can be managed.
Okay, and maybe the connection pots, Catherine, I'll come to you to have a go at the connection pots, but then what does kind of the ideal outcome of the connection reform look like for you?
Okay, so connection pots, this was the idea. People are probably familiar with perhaps the terminology of TMO4 plus, which was what NESO.
The worst acronym in the world.
Joe's words,
Save
not
the-
mine.
save the
Sorry.
contrarian view for later.
Regardless of what the acronym stood for, that was the kind of first working through of connections reform, and it introduced the idea that there'd be some sort of criteria that you had to meet to get into the new queue, and that criteria was called Gate 2 criteria, and it was broadly speaking going to be land rights. The world has moved on, right, quite a lot, quite rapidly, and we've introduced this second idea of connections being aligned to what the Labour government are calling the Clean Power 2030 plan, which, sets out a specific, well, in fact, sorry, the actual plan is going to be published in a couple of days, so we don't know what it sets out, but we are expecting it to set out some kind of overall gigawatt targets for the amount of, wind, solar storage that we need to meet that kind of clean power objective. And the idea is that will be subdivided into zones around the country. There'll be zones at transmission, zones at distribution, and within each of those zones, there will be a set of pots. So solar, for example, in, perhaps South Wales will have a pot, so a megawatt allocation. It might be 500 megawatts at distribution, it might be 2,000 megawatts at transmission, but a kind of effectively a cap on the amount of that technology that we are anticipating the network will connect between now and 2030. And the controversy, this is quite a good idea. As an engineer, I love it. We can design really well once we've got things like a kind of set criteria of pots of different technologies. So we could design a really efficient network. So that'd be great. But the controversy is obviously how you fill the pots, which projects make it in and which projects don't. And the proposal at the moment is that projects will make it into the pot or not, based on their planning status. So you fill the pot first with projects that are consented. If you've still got some room in the pot, you put in projects which have submitted their planning consent but not yet got consent. And then if you've still got some left over, you put in the projects which have just got their kind of land rights. So that's where, coming back to Joe's point, this idea of if most of your pot is filled with projects that have just got land rights, maybe your pot should be inflated a bit to take account of that. So that's the kind of pots idea.
I was also going to timestamp your comment about the Clean Power Plan in that today is the 12th of December. And so when this comes out, we will have a fully fledged Clean Power Plan.
Hopefully.
I like your confidence.
Yes. Okay.
I'm sure we will.
Okay, sure we will. Okay, and then from the pots to your view of what a ideal outcome on connection reform would look like.
Yeah, so I think I echo a lot of Joe's points, definitely the point about kind of attrition. I suppose the other point for me perhaps is that as I said, this kind of idea of pots, it does give us a lot of opportunity to optimize. I think that for me, connections reform for the first stage of it, so going out to 2030, is like a big sort of 80-20 exercise, i.e., it's a bit rough and ready. Time is sort of the essence. We could spend years getting this absolutely right, but it would have no point because effectively everyone would have been delayed. We'd have carried on perpetuating the kind of queue issues we have today. So we've sort of got to move fast. And I think one of the reflections of that is that it won't be perfect. So actually kind of being quite clear about what we're implementing. And I agree that actually there has been a lot of work that's gone into the proposals. They've changed, they've iterated, they are iterating still, right? So I think that's something that we should all be quite conscious of. We've had lots of consultations and things, but actually NESO's plans have been in the background, changing again and again to reflect that those kind of feedback responses. So I think lots of things are changing. We sort of now need to get to a point where we fix that methodology. It won't be perfect. We probably need to ensure, because it's not perfect, there are some undesirable outcomes. One of the biggest undesirable outcomes would be that actually everyone has to pause everything for the next year whilst the engineers, I'm afraid, go away and restudy the networks and work out exactly what the impact is and when people can connect. We don't want to do that, right? If you're a project that was due to connect in 2026, 2027, you need to be making investment decisions now or next year. So we want to kind of get that sort of investor sort of hiatus risk out of the way. So I think there need to be some sensible exemptions. There's been a recent announcement from NESO, an open letter to Ofgem, which outlines some potential exemptions, which I think is really great. So
let's do those exemptions.
Yeah. So the NESO have proposed that people are probably might be aware that the original proposal was that pretty much everyone would be caught up in connections reform. So you'd need to wait until the end of next year to work out whether or not your connection date was still valid. The only exemptions were projects already in construction who were going to be complete by the end of 2026. Based on feedback, NISO have proposed adding to that list of exemptions any project which by the 20th of December, so probably by the time this has gone out, had submitted their planning consent and receives that planning consent for their project prior to the implementation of connections reform. So sort of expected kind of May, maybe April, May next year. So projects effectively which are consented by April, May next year would be in the clear. They would be able to proceed
as long as they've submitted planning by the 20th.
As long as they've submitted planning by the 20th of December, yeah. So if you were, really quick turnarounds for kind of smaller projects wouldn't be allowed. But so that's one exemption. Another really important exemption is that something which has a government contract, like a connection for difference, a CFD, would be automatically exempt, which is great, right? So the projects that we think we need for the, to keep the capacity.
And this is to Joe's point, right? So if you've got that contract for difference, the chances are you've taken FID on that project. You are going to be building it.
Contract for differences actually do have various checklists and things that you have to meet in order to get the contract in the first place. You have to have planning. You have to have a grid connection. You have to meet certain milestones, and there are penalties if you don't connect. It's actually probably better designed than some of the contracts that we use for connections in a quite an unironic way.
Yeah, there's perhaps more kind of diligence on that. So those are the really big additional exemptions. I guess, Ed, you can probably put a link to the letter.
Absolutely
yeah,
can.
So by all means, go away and read some of the footnotes. But those are the biggies. So from that perspective, I guess what I think good looks like is we're already doing some of it because we're protecting that kind of risk against investment hiatus. We're moving at speed. We've moved at speed already. We do probably need to get to this point where we pin down the pots and that needs to happen sort of ASAP. The worst case, I think, would be if we carry on drafting and redrafting pots and it overlaps into the point when connections reform has technically been implemented, because you could get to a scenario where NISO are asking customers to sort of put their hand up and say, are you ready? Are you gate 2 ready? And they haven't declared what the goalposts are, so they could almost do a sort of wait and see. We'll see who applies to us and then we'll decide what our final numbers are. I think that would really, really impact on industry confidence. So setting the numbers, acknowledging that they won't be 100% and therefore put some attrition in.
Okay.
And following on from that, one of the things that I actually really like to get out of grid connections reform is just transparency of rules. So investors hate uncertainty, as everyone seems to say, or everyone knows. And grid connections has historically been quite a grey thing. There's always grey everywhere you look, right? Whereas with this grid reform, we actually can really detail out a lot of the rules that govern things like, talking about like the pots, like there is a clear plan, it's a strategic plan. Everyone knows everyone's playing by the same rules. Same with like what how do you, I know we're going to come on to this, but how do you change the technology, or how do you amend your connection? How do you delay your connection? Like all of those rules need to be very clear so that everyone is able to play by the same rules. I think in grid connections, there's always been a little bit of those who have the information or those who are able to just talk to the networks often get a better outcome than those who don't know the rules.
And I think maybe one thing that kind of strikes me is that if we do the 80-20 rule and we kind of set out what it looks like, from day 1, day 2, information changes, and all of a sudden we might have more demand in an area, or a certain technology might be performing better, or certain technology might be performing worse. And yes, individuals might choose to change their connections, which as Joe says, we'll come on to. But is there kind of allowance within kind of the grid process to say, hey, we're racing towards 2030, but actually in 2028 we're going to have a little true up. We're just going to make sure that actually, like, we just need to tweak the numbers. Is that baked in, or is that kind of not really thought of?
It's a really important point, because it's not currently baked into the baseline proposals, but it is one of the sort of like alternatives that's been worked up to say, actually, exactly, great phrase, that kind of true up idea of reflecting, has this worked? Do we need to amend some of those levels? I guess the counter to it is that realistically, we will set some of these pots and that will prompt, investment decisions, hundreds of millions of pounds spent on, really quite specific assets. So the transmission owners, for example, but any of the network owners kind of need to be told, this is it. Go buy stuff, build stuff, not this is it for now, but we might tell you to stop in 18 months' time. That kind of mixed messaging in the past has been really detrimental to the speed of delivery. So I think perhaps it's more go now, build big, build fast with certainty. Maybe there should be a reflection exercise point, but that's a kind of retrospective reflection to see if there are any minor tweaks as opposed to a big hiatus.
So if not in 2028, when does grid connection reform have its moment of reflection?
Well, I think the
Christmas 2025.
Yeah, Christmas.
I think in a year's time, we might, in theory, we will have the answer to what the sort of what the new queue will look like.
Yes. I think NISO have been very clear. The great grid reordering is only happening once. It's a one-off exercise where they're going to change people's queue position. And I think that is a lot of that is because if you suggest that you might change it again in the future, it creates a lot of uncertainty for investment, which Catherine just said. But there is something they're doing, which is the Strategic Spatial Energy Plan, which is a follow-on essentially of the Clean Power Plan 2030. And the idea of that is to align the connections pots or the connection process with the planning authorities and what people are actually going to be given planning for, and trying to make sure that what the local authorities and government approve to build can be connected to the grid, right? So that in a sense is a true up, but it will be more of a pivot than a reconciliation or anything.
Perhaps the SSEP is more of an enablement of the Clean Power 2030 plan that gets set.
Yeah, it's sort of like an addition, right? Like it's the next generation. It's the next generation of the Clean Power 2030 plan. Yeah, exactly. And the other thing as well is
it'll hate its parents.
Yeah. NISO there is some flexibility in the reforms, right? So with these pots, the NISO has been very clear that you can move capacity between adjacent zones. At the moment, they say it has to be like a transmission to transmission zone or a distribution to distribution zone. It can't be transmission to distribution, which potentially is an oversight. But there is that flexibility there. And I think that's really important because, as you say, if one area, for whatever reason, they've got it a bit wrong and there's not as much that can be built there, they need to be able to shift that somewhere else in the country, right?
Okay. And so we now have this 80/20 rule, really clear plan to 2030. That's all going to be absolutely fine. Have we got a tsunami of projects at 2031 that are going to be waiting to build? Like how do we deal? Because if I'm building a project in 2031, I need to be planning for it now.
Yeah, I mean, I think so realistically, although perhaps the numbers are a bit misleading, although we talk about a Clean Power 2030 plan, the exercise that, Joe's great grid reordering that's happening once really is setting a queue out to 2035. So it's just got a first tranche of projects going to 2030, and then it's got a second tranche going from 31 to 35. So I think you'd be legitimately concerned if you were saying, well, I was thinking of building a new nuclear station in 2040 and I'm not going to be in this plan.
Although there are some designations for that. So
there are. I was going to say we do.
Long
lead
lead items or long lead projects, can be designated so that they get given a grid connection, even though it's past 2035.
So there's definitely not a cliff at 30 to 31. I think that has been thought about, and the proposals are really quite sensible. There's definitely more detail to be worked out about. At the moment, there might be some room for sort of some gaming. It kind of looks like it might be beneficial for some projects to sort of say, yes, I want to be in the 2030 tranche, knowing they're unlikely to quite make it, but it might make them more likely to get into the 31 to 35 tranche. So that kind of, there will be transitional kind of edge case issues, I guess.
And something to understand is that the NISO has purposely decided to create a queue up to 2030 and then a queue up to 2035. And the reason they did that was partly to do with attrition, right? They were trying to say, we're going to need some of those projects that are going to be given a 2031 to 2035, as they develop, may actually be able to come forward. And so when other projects delay or terminate in between now and 2030, those projects in 2031 and onwards can come forward. They can be accelerated. I think my concern over this is that it, again, going back to, I don't think it reflects how development business models work. It's really hard to accelerate projects. If you've got a connection date of 2033, you will plan for a 2033 date, right? You planning only lasts a certain amount of time in some situations. Although from what I understand, I'm not a planning expert. From what I understand, though, you can sort of get longer than the typical 3 years if you want. But generally, if you've got a later connection, you'll wait to put planning in, and you'll plan your procurement around that. To then accelerate is really difficult, because first of all, you probably will only be able to accelerate when the project delays, and the project is only going to delay when it has exhausted all options to keep the connection date it's got. So it will probably delay at the last minute with maybe, I don't know, a year, 2 years out from its connection date. You're then asking another project to go, you're going, right, come and connect in 2 years' time. They, particularly at transmission, they've got to do procurement. I mean, the supply chain at the moment for transformers, 400 kV transformers, is like 3 years. So I think it's a lovely idea, but I think doesn't quite appreciate the practicalities of accelerating a project.
But you're a little bit damned if you do, damned if you don't, right? So on one hand, you're saying it's really hard to accelerate stuff. On the other hand, if you kind of front load the queue, knowing that some stuff's going to drop out, you don't know which bits are going to drop out. And so you're giving this great big chunk of work near term. So it feels like...
I think.
As in NISO don't win.
Yeah, I mean, yeah.
Or UK PLC. I kind of disagree in the sense that I suppose what we see now is reality. There's that Joe's explained why it's so hard for a developer to accelerate, and developers sometimes delay. I think it's very important to recognise that transmission owners and network operators also delay. So we all put together a plan that says, great, in 2033 or 2028 we're going to connect this project, but often those network parties are fighting for the same supply chain. They've got some of the same constraints in terms of resource and workload, and it's almost inevitable that timeframes slip. So I think actually, there's almost like a level of saying, if you took those pots and you said, oh, actually, I think we need to inflate this by 20%, 25%. So we're going to basically let 125% of the kind of theoretical pot capacity into the queue. We're going to study all the reinforcements. And okay, so actually we're now building 125% of the stuff we thought we might have to build by 2030. But 25% of it's probably going to be late anyway.
And which is why I think you have to look at it as the status of those projects, right? Projects that have planning are more likely to be built than projects that don't. And projects that have a financial investment decision are almost certain to be built, right? So it's just acknowledging the risk profile of those different projects and building that into the pots and how you're designing the queue or how you're managing the queue.
I think to one thing Catherine was saying earlier, the phrase really quite sensible. I think if we can apply that to any part of connections reform, I think we're going to be in the right.
I feel like people have different opinions though of what really quite sensible is, right?
Okay, good. So I'm going to move us on to a topic that I think comes up quite a lot, and I think we're potentially going to see a lot more of, which is amendments to queue. So let's say I've got a battery storage project, it's 50 megawatts, but I'm really excited about the prospects of co-location with, say, solar. What happens next?
So, shall I go first? Okay. So, I sat in 60 working groups for grid connections reform, which was the highlight of my life. One of the discussions in that, which took quite a few working groups, was the talk of a significant change and a material change. So, a significant change is something that requires a modification application, a mod app, i.e. you have to apply to the network for approval to change your connection. The other thing was material change, which is a change to your connection, which requires you to be modeled, talking about the assumptions that are made when we plan a network. So requires your project to be modeled at the back of the queue. So with lots of all the other generators in front of you. And there is a lot of discussion still ongoing about what is a significant change, or what rules are what would require a significant change and what would require a material change. And I focus on material change because that's the more important one, because it puts you to the back of the queue. NESO are planning to issue a guidance, and they plan to do this before connections reform is implemented next May. So that document will hopefully be clearly state, if you do this, this or this, you will be modelled at the back of the queue.
Yeah, and I suppose the it's great wording, isn't it? I know exactly the sort of the history behind all these words. I think you'd probably almost want to call a significant change a tweak.
Yes.
One of them's a tweak, one of them's a material change. But I suppose also, just before that guidance comes in, Joe, and before that kind of terminology is officially used, the current process is effectively that anyone who holds, I guess we're sort of focusing at transmission here, anyone who holds, for a large scale project who holds a transmission connection agreement, they have to they apply, they do this modification application to make a change, but they're kind of taken on a case by case basis, and the system operator and the TOs evaluate those, and you could put one in tomorrow, and as we record in December, and they would have to evaluate what the impact was of adding, say, solar to your project, and then you might not go to the back of the queue. That might be perfectly possible. You keep your connection date, and so completely understandably, there is a huge amount of change going on, because lots of people have looked at these draft pots and things and thought, well, I can sort of see the way this is going. Maybe I need some other technology to kind of try and evidence that my project is needed, or to help my business case. So there's huge amounts of mod apps being submitted, or variation agreements. And one very practical point is that you've got a whole load of network operators who are just going, whoa, stop. I've got to get my network ready for this massive change coming in, connections reform. I can't do that if I'm still having to churn the handle on, I think I was with Scottish Power Transmission last week at their Connection Summit. They said they were receiving 3 times the normal volume of modification requests at the moment. And they just put out a plea to say, to the regulator, we can't carry on doing this. So I think it's very likely that we will see some kind of what we call them transitional arrangements, but essentially a kind of drawing a line in the sand that says, right, now everyone has to stop. You won't be able to put in mod apps or carry on changing until connections reform has been implemented, to give the engineers studying the networks a bit of breathing space. So I think we might be looking at a very limited window for people to play around with their connection.
So, Catherine, one thing, just before we go on any further, I'd really like to get some clear examples around a significant change versus material change.
Okay, so if we think of that kind of significant change being the sort of tweak, so that example of that would be a generator. Perhaps they're a transmission generator. They have a 500 megawatt solar farm, and they've got 500 megawatts of tech, which is the export capacity. They want to modify that so that they're now going to be a solar farm and a wind farm. So they're going to still keep their 500 megawatts of tech, because they're going to kind of balance that behind the meter, but they're going to, some of their solar they're now going to build out as wind. That would be considered to be a kind of a tweak. Effectively, they can just submit a modification application and they will effectively keep their place in the queue. By comparison, if you're a 500 megawatt solar farm and you decided what you wanted to be was a 500 megawatt battery, they would need to, that would be a change in their import capacity. So they haven't applied for any kind of capability to charge that battery. That will need kind of restudying, which is likely to take them to the back of the queue. So that kind of a fundamental change in technology, which also triggers a change in your import capacity or export capacity, is a material change.
It feels kind of odd, right? Because going from solar to wind will definitely change how that thing performs, and will definitely change how it will impact the grid.
Well, do you want to disagree with that answer?
No, well, not quite. But no, you're exactly right, because the problem is, as this conversation shows, is it's a grey area, and the general term used is, does it have a detrimental impact on other users? Which is a really vague way of thinking about it. And basically means that you, as a developer, have a discussion, that sometimes might be quite heated, with the network engineers, saying this does or doesn't, they're trying to explain this doesn't have a detrimental impact on the users. They're going, well, maybe it does. So and this is where I was trying to go back to, it would be helpful to have rules, very clear rules and clear guidance, because it would stop the back and forth and stop developers feeling like they are being mistreated, or even worse, is one developer, one project being treated differently to another. And that at the moment there is a real risk of that, just because the rules are not defined. So different people may have different subjective opinions of what is material change at the moment.
Mm-hmm. And just before we move on to the final two questions, I'm just hoping to get an idea of of that queue that we've got. Is it kind of 1% that's coming to kind of tweak things? Is it 50%? Is it 100%? What's your gut feel?
Well, I mean, I think there are whole swathes of the queue, like, for example, the battery swathe, so people who had standalone storage projects, I would say, are the biggest, they're likely to be the biggest losers from connections reform, and therefore I think it's understandable that there's the maximum amount of kind of tweaking or radical redesign that's being considered in that. And the battery part of the queue is a really big one. So I'd go up in the kind of, 40-50% of the queue is looking to potentially do different things with their connection.
Yeah, there are monthly stats on connections which the NESO publishes and ENA publish. We'll have to look at that when it comes out for the next month. But I agree. I think it's going to be a higher than historic amount, because there are a lot of people who are trying to work out how they're going to set themselves up here for connections reform, and whether that's changing their technology or adding technologies, or even just trying to modify their date. I'm not entirely sure why you would do that, but at the moment, because grid reform is going to make you do that anyway. But people are just trying to work out how they're going to react to this. Yeah.
Okay, I think that's really useful for people who'll be listening to this with projects, trying to just understand what the landscape looks like. It changes so quickly that unless you're in it every day, it's so hard to kind of actually really understand how it'll work. So That's been really useful. On to the final two questions. Now, I gave you a choice. We usually ask people to...
Oh, wait. Oh, no, I hadn't thought about this. Sorry, I interrupted that.
So I gave you a choice. You could either choose to plug something, or you could put forward a contrarian view, and it's one each. So, Catherine, would you like to go first? You can either plug something or bring forward a contrarian view.
I am going to plug something, which I realise is the easy choice, Ed, and it's because it's something which maybe sounds boring, but is super important. So as we're recording in December, the Ofgem have released yet another consultation, and which I know is not going to be popular news to people, but this one is, I think had a great chat with Ofgem, and they sort of described it as an opportunity to even the scales, a reflection of the fact that connections reform has made things really quite difficult for developers, and that we do have this quite unbalanced landscape where, you sign a connection agreement with a network operator, that sort of, where you hold all the risk, they're allowed to change it. We're introducing all of these kind of higher bars, so you have to kind of additional hurdles you have to jump through, and yet the kind of landscape for the regulation of the networks has remained really unchanged. So like I said, it wouldn't surprise me if we end up delivering a lot of these network reinforcements late and things like that, so people's connection dates slip back. This consultation is about some pretty punchy measures that could be introduced, like, liquidated damages on network operators for being late, some quite significant regulatory commitments to make, to really hold network operators to account. So it's it's called the end-to-end review, and I'm sure we can pop a link to it, but it's almost like a tell us your pain, and I feel like a lot of developers have a lot of pain. So, it's a group therapy session for everyone.
Okay,
so so we all need a bit of group therapy probably, and Ofgem are offering to host it. So reply to Ofgem. That's my
100%. Great plug. Joe, over to you. Which way are you going?
I'll go for a contrarian view, I think, which is always risky. But I actually think on the theme of consultations, I actually think we potentially haven't had enough consultations.
And that is a controversial opinion.
And there is at least one more consultation we need, which is on POTS, the POTS that the plan that the government is about to issue. It's not being consulted on, and it needs to be consulted on, and therefore I would love another consultation.
That will be contrarian. Congratulations. That's a genuine contrarian view. I love it. Okay, well, both of you, thank you very much for coming on. You've been fantastic guests, and I think people listening in will have learned a huge amount. So thank you very much.
Thanks for having us.
Thanks, Ed.
Thank you for listening to Transmission, a Modo Energy podcast. Transmission delivers conversations from industry leaders and experts exploring energy markets and the operations and technologies related to grid-scale battery energy storage. Check out our other episodes by searching Transmission wherever you get your podcasts. Check out the Energy Academy, our video crash course on how markets in Great Britain and ERCOT work, or head to modoenergy.com to see our written research. Thanks for listening.